Thursday night homework. Problem 1. A mechanic charges a $50 initial fee plus $70 per hour to repair your car. Write an equation, let's circle that describes the relationship between the number of hours X the mechanic works and the amount Y he charges. So let's define the variables. X equals hours. Y equals the amount charged. So amount charged. First, let's come up with an equation. So the amount charged equals $50 initial fee plus translates to addition $70 per hour. So 70 times X. X represents hours. So now let's plug in some values for hours worked. So when the mechanic works 0 hours, he gets the initial fee of $50, right? Substitute 0 for X, 70 times 0 is 0, but he still has the initial fee of $50. Plug in a 1 for X. When the mechanic works 1 hour, 70 times 1 is 70, plus 50 is 120. So we can see the pattern is we're adding $70 each time to get the amount charged. So 70 is 260 here. And then when the mechanic works 4 hours, he earns $330. Okay, problem 2. Same type of problem. A telephone company charges a service fee of $6.05 per minute. Write an equation that describes the relationship between the number of minutes, X, so let's define our variables, X equals minutes, and total cost, Y. Y equals total cost. Always define your variables. So let's create the equation. So total cost, Y, equals a service fee of $6 plus 5 cents per minute, 0.05 M. Okay? So we can plug in any values for X. I'm going to plug in 10, 100. I actually could have started at 0. I'm going to plug in a 0. I know I'm not going to go in order, but I'm just picking easy X values so that I can use mental math to calculate my Y values. Let's plug in 1,000 and then 10,000. So when I multiply, let's start with 0. When I substitute 0 for M, at 0 minutes, you're still paying the service fee of $6. So $6 goes here. At 10 minutes, the reason I chose 10 minutes is all I'm going to do is move my decimal one place to the right. When I multiply 0.05 times 10, I move it by a tenths place, and I get $6.50. When I multiply 0.05 times 100, I move my decimal a hundredths place, so tenths, hundredths. That becomes $5, so 5 plus 6 is $11. When I multiply 0.05 times 1,000, I move it 3 places to the right. 1, 2, 3, and add a 0, so that becomes 50 plus 6 is $56. And multiply by 10,000, that becomes, instead of 50, it's $506. And again, you can use any X values and just substitute those values into the equation to find your Y values. Number 3. Lois weighs 170 pounds. She is losing an average of 3 pounds per week. Write an equation that describes the relationship between Lois's weight x, so x is her weight, again define the variables, and number of weeks y. She has been dieting. So y equals number of weeks. She weighs 170 pounds, so she starts at 170 pounds. She is losing an average of 3 pounds per week. So losing weight means we're subtracting weight from her initial weight of 170 at a rate of 3 pounds per week. So 3 times x would be our equation. And now let's substitute 1 week, 2 weeks, 3 weeks, 4 weeks, and 5 weeks in for x. And let's see, when we substitute 1 week, we get 170 minus 3, which is 167 pounds. Substitute 2 weeks for x, we get 170 minus 6, which is 164. So you see the pattern. We're losing 3 pounds every week. And 155. Next question. We have an equation, y equals 3 times x plus 2. Let's plug in some x values. So when x is 0, what is y? When x is 1, we need to find y. When x is 2, when x is 3, and when x is 4. So to find y, the process is y equals 3 times your x value plus 2. So when x is 0, y is 2. When x is 1, y is 5. When x is 2, y is 8. But the pattern, you can see the pattern is we're adding 3 each time. That's what that 3 in front of the x translates to. So we're just adding 3 each time. Now we need to take this data from our table and graph it on the coordinate plane. So when x is 0, here's when x is 0, y is 2. So right here. When x is 1, y is 5. When x is 2, y is 8. And we're going to go off the chart, so let's just stop there, connect our dots. It makes a straight line because there's a constant pattern to our y value. Number 5. Same type of question. But this time we're incorporating a fraction into our equation. So let's be strategic when we think of the x values. So let's plug in 3. I'm going to plug in multiples of 3 because my denominator is 3. So 6, 9, 12, and 15. That's going to make it real easy to multiply by negative 1/3. So we know the process is negative 1/3 times my x value, which is 3, so times 3, which is the same thing as 3 over 1, plus 2. Well, let's think about this. We know when we're multiplying fractions, we multiply straight across. So 1 times 3 is 3, 3 times 1 is 3. I know 3 over 3 is equivalent to 1, but there's a negative sign, so it's negative 3. Negative 1. Negative 1. So negative 1 plus 2 is 1. Now let's substitute 6 in for x. So we have negative 1/3 times 6 over 1 plus 2. So 1 times 6 is 6. 3 times 1 is 3. 6 divided by 3 is 2, but there's a negative sign, so it's negative 2. Negative 2 plus 2 is 0. So when x is 6, y is 0. Now let's substitute 9 in for x. So I have negative 1/3 times 9 over 1 plus 2. 1 times 9 is 9. 3 times 1 is 3. 9 divided by 3 is 3, and there's a negative sign, so it's negative 3. So negative 3 plus 2 is negative 1. So we can see the pattern that's developing. So we're just going to, this is going to be negative 2. So we went from 1 to 0. We're just subtracting 1 each time. This is negative 3. So once you identify the pattern, then we can just continue that pattern. So now let's plot when x is 3, 1, 2, here's 3, y is 1, goes right here. When x is 6, y is 0. When x is 9, y is negative 1. Let's see, 9 is right here, negative 1. So look at, our line is going a different direction than in the last graph, and it's going a different direction because the first number is negative, and so the pattern is negative. So in order to represent a negative number in front of x, the line has changed direction. So instead of going this direction, it's now going that direction to represent a negative. Lastly, number 6. The graph of the line y equals 4x minus 2 is drawn on the coordinate grid below. Directions. Write yes if the table of ordered pairs contains points on the line. Write no if the table of ordered pair does not contain points on the line. So we just need to plot these. Negative 2, 10. Negative 2, negative 10. 1, 2, 3. See, negative 10 is going to be down here. That looks like, if we continue this line, that looks like it's going to be on the line. 0, negative 2. 0, negative 2 is here. That's definitely on the line. 1, 2 is on the line. And 3, 10. 1, 2, 3, up 10 would be right here. So yes, this table is on the line. Let's do the next one, 4, 14. That's going to be off the grid, so let's not worry about that one. Negative 2, 10. We already said yes here, negative 2, 10. What about 0, negative 2? Yes. 3, 10, yes. So this would be another yes. So a lot of these ordered pairs repeat themselves. Negative 2, 10 is here, so yes. Negative 1, 6. Well, that's a new coordinate, so let's plot it. Negative 1, 6 would be right here. No, that's not on the line. Let's see if any of these points repeat themselves. Let's not worry about that because that's going to be off the grid. Negative 2, 10, we already said yes. 1, 2, yes, it's over here. 2, 6, 2, 6, let's see, 1, 2, and then go up 6 would be right here. So I would say yes to that one. So yes, yes, no, yes.